Okay, so a couple of things. Three-dimensional shapes. If a shape is made mostly out of rectangles, right, then it's a prism. If it's a shape that's made mostly out of triangles, then it's a pyramid. Who made the pyramids?
The Egyptians.
The Egyptians. Good. Put that picture in your brain. I'm sorry.
It's true.
Okay? The Egyptians made the pyramids. The two things that you get mixed up on the most are which ones are the prisms and which ones are the pyramids. They're very different. Pyramids are made mostly out of triangles. This is what the Egyptians made. Okay, so when you go to answer a question and you're stuck because you can't remember which one was which, right? Pyramids, triangles, Egyptians. Prisms, rectangles. Okay, yes, the bases are different shapes, that's fine, but this one is made mostly out of rectangles. It will for all of them. I agree with you, but there are some people who have a hard time, so we have to make sure we can distinguish the differences. Okay? Now the other thing is faces with an F and bases with a B. Faces with an F is all flat sides. Bases with a B are not the ones on the top and the bottom. Bases with a B are the two sides that are parallel and congruent. A rectangle on a prism will almost never be the basis unless it's a rectangular prism. Are you with me? Okay, this is never going to be a base. Okay, unless all the sides are rectangles. Okay, is that open? Ooh, don't share all my secrets yet.
You dropped it right there.
Very good. Okay, does that make sense? Okay, so let's go quickly through this little section. Prisms are made mostly out of what? Rectangles. Pyramids are made mostly out of triangles. And then you have your cylinder and your cone. You're good there, right? Ice cream cone upside down? Good. So let's take a look at A first. Name the base of this shape.
Square.
Or rectangle. It's a square rectangle. Excuse me. I don't know for sure if all the sides are equal or not. But I know all the angles equal 90 degrees. So it's either a square or a rectangle. How many faces with an F are there? How many faces are there? 5, right? You have the square and 4 triangles. How many edges?
8.
You have 1, 2, 3, 4, 5, 6, 7, 8. And what in the world is a vertices?
The points.
The points. How many points do I have?
5.
Oh, wait.
5. Are we okay? B. What's the shape of the base with a B?
Circle.
The circle. Remember, it's just the flat sides. How many faces are there?
3.
2.
2, the 2 circles. How many edges are there?
2.
0.
None. These are all curves, right? There's no straight flat side, so there are 0 edges. How many vertices? 0. Very good. Okay, I want you to try 1 and 2. All right, somebody tell me what's the name of the base for number 1?
Circle.
Circle, very good. How many faces are there?
1.
How many edges?
0.
And how many vertices?
1.
Number 2, name the base.
Doesn't have 1.
There's none. Very good. There is no flat surface. How many faces?
0.
How many edges?
0.
How many vertices?
0.
Good. Number 3, name the base.
Pentagon.
Pentagon. Remember, the bases are the 2 that are parallel and congruent. So this one is a pentagon. How many faces? 7. How many edges?
15.
And how many vertices? 10. Vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. And number 4, tricky, be careful. What's the base?
Triangle.
Triangle. Remember, you'll never name a rectangle unless all the sides are a rectangle, right? How many faces?
5,
5. How many edges?
6, wait.
9. Very good. And so I have 9 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Is there a short way to count those?
Yeah, it's a triangle. There's 3 on each side, right? And then you're going to have one line connecting each of those corners. Right? So the shape of the base is a triangle. You have 2 triangles, and then you're going to connect them.
Can you just like
So it's
square
3
it?
times bigger, huh?
Can you just square it?
Where is it?
3 squares.
Well, if it's a pentagon, it would be 5 squared, which would be 25. So on this one, were there 25 vertices? Were there 25 edges?
Try.
All right, how many vertices on number 4?
6.
6. Are we okay? All right. On the next one, this back over here, I'm not totally concerned about these platonic solids. A tetrahedron, tetra means
4.
4,
Yes.
because there's 4 faces. A hexagon means
6.
there's 6 faces. An octahedron means
8.
there's 8 faces. Are we good? I'm not totally concerned about those though. Okay? Not totally concerned about those. But down here, do you know the difference between a cylinder, a cone, and a sphere?
Yes.
Okay? So make sure you pay attention. What I'm more concerned about in this unit is right here. We've been talking about 2-dimensional shapes. So right here I have a triangle on the end of my straw. Correct? Have we been talking about triangles?
Yes.
Okay? How can I make this triangle a 3-dimensional figure? By rotating it around the straw. So as I spin this triangle around the edge of the straw, what shape would it make? A cone. How do you know it's a cone?
You're just spinning it circular ways?
Right, I'm spinning it, and this line right here would be the radius of the circle, wouldn't it? Okay? And then this point is just a point, so it's going to stay in one spot, which will make that cone. Okay, this is going to be your study of pre-cal. This is when you go to pre-cal, what they're going to do is they're going to start slicing figures. Okay, what happens when I spin this shape? What would it make? Which one?
Sphere.
Which one?
B.
B, very good. Number 1's going to go with B. What's number 2? Careful, it's tricky. What would number 2 be if I spun it? Which one?
D.
D is in dog?
Yes.
Okay, very good. Why not C?
Because that's
There's something missing in the middle. So which one of these would C be?
6.
6 or 7?
6.
6, very good. You notice that it's away from the straw a little bit, or the line. Are you with me? And that's what's going to make that hole. Number 3, F, very good. Number 4, E. What shape is number 5?
G.
A trapezoid. Good. When I rotate a trapezoid, what am I going to get? Half of a cone. Very good. Because a triangle makes a cone. So remember, a trapezoid is a triangle with the top cut off, right? Okay, so if I cut off the top of a triangle and I get a trapezoid, which would give me the cone with the top cut off. Same idea. Okay, what about number 7? A makes that donut, right?
Yep.
A hole in the middle. Okay, kind of cool? All right, so let's take a look at some more fun things. Now we're going to start talking about what happens if I slice a shape. Okay, right here in my hand I have a yellow cone. And I'm going to slice this shape open. What shape does it make?
Smaller one.
Okay, think Algebra 1.
A parabola.
A parabola, very good. Okay, so a parabola is nothing more than a slice of a cone. Did you always wonder what you need to know about a parabola? Okay, well it's part of a shape when I slice it. But if I slice a cone a different way, now I have the red cone. What happens when I slice it open? I get what shape?
Cone and
A circle. Okay, these are called cross sections. When I cut a shape and I look at the inside of it, that's called a cross section. So this is going to give me a circle, correct? Okay. What happens if I don't cut it straight across?
you get like a triangle.
Then I get a what?
Oh,
An oval. Very good. So that's where all those shapes come from, is when I cut three-dimensional shapes into different pieces, it gives us different shapes. Are we okay? And how you study it, what you've been studying up to this point are just those flat shapes. As you get into the higher levels of math, then they start looking at the shape as a whole and how can I get those other shapes? Where can I start applying that information? So right here, let's take a look. Would somebody put those lights out for me so y'all can see this? Okay, so if I take a cone, so what they have right here on the left, that's a three-dimensional shape. This right here is the slice. What shape would it be? So if I take a cone and I slice it, I'd make an oval. Could it just be an oval?
No.
Could be a parabola, right? That was my yellow
Yes.
cone that I showed you. Okay, but keep watching.
Circle.
Okay, so it depends on where I slice it. Okay, I can make it just rotating it around. I can also slide it up or down to make it bigger or smaller. Okay, and then I can make the radius also changes. But what happens if I change it to a cylinder?
It stays the same.
Will it always be a circle?
No, it doesn't stay the same, but it stays the same shape.
It does?
because if you do it sideways, slanted, it's gonna be an oval.
Okay. What other shapes could it be?
Square.
A square? What?
If you had a rectangle.
How would you get a rectangle?
Rectangle style.
A prism.
Okay, think about it for a second. They're going to tell you to slice it vertically or horizontally. What you see right here is it sliced horizontally. But what happens if I slice it vertically? Great job, Brian. Okay, everybody else doubted you. Look at you go. Are you with me? So here, I even still get to that square or rectangle, depending on how tall the cylinder is. Okay, but I can also get to that parabola shape, right? Are you with me? Are we okay? So there's lots of them, and you're going to have to think about which way they slice. That's not going to change anything. Okay? What about a pyramid? Okay, start with the basic pyramid.
Oh, just move the width of it. Oh, wait, not that. No.
Okay, look at all those different shapes, right? So it depends on where you slice it as to what shape you get. What shape is that? Okay. I know, isn't that crazy? You never thought about that, did you?
Nope.
Nope. So what happens if I change it from triangular to a square pyramid? And then from there, what shape is that? So kites might be important at some point in time. Okay?
Compass.
Possibly. Uh-oh. Whoa, what is that? A pentagon? No, that's not what a pentagon looks like.
That's what I'm saying.
It has 5 sides. It's a pentagon. But what you're used to seeing is a regular pentagon, right? Because we've been studying regular pentagons. Any 5-sided shape is a pentagon. Any 6-sided shape is a hexagon. But we've just been studying the regular ones so I could teach you some information about them. There's all kinds of irregular shapes. And we just haven't studied them because there's no hard and fast rules, is there? If I teach you about regulars, then what we can do is break this into shapes that we do know, where I can start slicing it here, and then I have a triangle and a trapezoid. Right? That's what you do with irregular shapes, isn't it? Isn't that what you did when we were doing the composite figures? Okay? So, I don't want you to get stuck too far. I just want you to start thinking that that no matter what that shape is, okay? You with me? So it depends on how I slice it. It depends on what shape I have, how many sides I have, okay? And which direction I slice it. Pretty cool? Pretty cool. All right, so now let's take a look back here. So on number 1, 2, and 3, just jot down on your paper, what do you think are those cross sections? What shape would make up those cross sections? Okay, tell me, what do you think number 1 is? A rectangle, very good. It's like if I were to connect these two, right? That would absolutely be a rectangle. What about number 2? Good, I'm cutting off that corner, aren't I? And number 3, trapezoid, because these two lines are going to be parallel, aren't they?
Yes.
Aren't they on the bases?
Yes.
But are they the same length?
No.
No. And then if I connect them, that's absolutely going to make a trapezoid.
So that's questionable because it's close enough where it looks like a triangle, a rectangle.
You're right. You're absolutely right. And there are going to be some times that it might be hard. You're going to have to just say, well, what do I know about it? What can I do? So, for instance, I know that these A, B, and C, D are both parallel, right? I know that for sure. But do I know A, D, and B, C are parallel? No, they aren't, because these two sides back here go back and touch. Are you with me? So there are going to be some times when you're not quite sure. So on your paper, I want you to look at 1, 2, 3, and then 4 through 7, and I want you to name what would be the cross section. Okay, somebody tell me, number 1, what did you put? Circle. Number 2, what did you put? Oval. Very good. Be very careful when you have that slant, it's going to make that oval. Number 3, what did you put? Rectangle. Good. Number 4. Rectangle. Very good. Number 5. Square. Number 6.
Rectangle.
Rectangle. Number 7.
Triangle.
Triangle. Easy stuff?
Yes.
Good. Good, good, good. Okay, next page. Okay? The cereal box. How many pieces of cardboard do they make a cereal box out of?
Like this.
One piece of cardboard?
1. That file cabinet back there. How many pieces of metal do they use to make it? 1, maybe 2. Okay? But more than likely as many as, like 1. They can make it out of 1. In this drawer, how many pieces of cardboard did they use?
1.
1. All they did is they cut out a, what's it called? Anybody know?
Slit.
A rectangle.
Okay, so they cut out a net. And then they come back and they crease parts of it. Have you ever tried to build a box?
Yes.
Yeah, and it came out horrible, didn't it? And it was all flimsy because what did you do? You cut each side out and then you tried to tape it or glue it. And it didn't hold very sturdy, did it? Okay, but if I use 1 piece of cardboard and I just slice it, right? And I make a net out of the shape I want. Then I can fold those pieces in, right? Just like a pizza box is a net, right? 1 piece of cardboard, and now it's pretty sturdy. This is your turn-in tray. Huh?
Looks great.
No, it's just a piece of cardboard. It's duct tape to hold on a pretty design. This is just your in tray that we use. Does that make sense? So that's what's going to make those sturdy. Go home and open up a cereal box. It's just 1 piece of cardboard. It's what makes it sturdy. They just fold it and crease it so that it'll stay together better. Okay? So nets are very important. Look around, watch. Most boxes are nets. What would this be a net for? Cylinder. Okay, now I want you to think very carefully of what I told you about shapes. Number 2, what kinds of shapes do you see? Rectangles. So what shape is made mostly out of rectangles? A prism. What kind of prism is this one?
Rectangular.
Good, this is a rectangular prism. What about number 3? Why is it a pyramid?
It's not. It's all triangle.
It's triangles. You see triangles, don't you? So this is absolutely going to be a pyramid. What kind of pyramid? Good, this is a triangular pyramid. Okay, now, sometimes trying to find these measures is a little difficult. But what I want you to do is I want you to take the measurements from the solid and put it onto the net. And what I'm going to do is I'm going to random generator, and you're going to come up and we're going to talk about some things. Is that okay? All right, so I'm going to give you a few minutes, and I want you to look at these numbers, And I want you to find out where do you think they go on the nets. And then I'm going to random generator here in just a minute, and you're going to come up and put down where you think they go. Ready? Okay, so absolutely, we know our smallest sides are 5, correct? All these little pieces right here are going to be your 5. Your 16, so all of these are going to be your 16s, right? Notice on your 15, this is 15, but this is also 15. Because when I fold it up, won't those two have to connect to each other? Okay, same thing over here. This is your 15 and this is your 15 because they're going to have to connect to each other. So be very careful with things like that. All right, very good. So we absolutely have the 28 is going to be the line that connects those two triangles, correct? That is considered to be your height. So if I look at this shape right here, my height is the line that connects the two triangles. On this cylinder right here, where did it go? On my cylinder, the height is not the diameter of the circle. The height is the line that connects the two circles together. This is your height. I don't care what way I put it. Your height is the line that connects those two bases. Same thing on this shape right here. Okay, these two are my hexagons or pentagon. There's a pentagon. This is your height. It's the line that connects those two. It doesn't matter which way I set it. Okay? This is your height. It's the line that connects the two bases. Everybody got that? Good. And you absolutely put it correctly where you have your smaller pieces, your 8s, right? Okay? And these are going to be your 8s as well, right? And then your 17 is going to be your long side. So this is your 17, but this is also your 17.
Well, no, it's 15 of them.
But remember, that's your flat piece. That's going to be, this is going to be your 15.
Oh, that's one.
And this is going to be your 17, which means this is going to be 17.
So that means the
Right, so
piece will be 15 too.
this is going to be your 17. So this piece right here would be your 15. Right. Okay, so be careful because they have to wrap. Whatever side you have for your triangle, your 8 and your 17, then right here, this side, and this side has to be each one of those sides of the triangle because it's going to wrap around it. Does that make sense? Good. Let's talk about it for a second. So think about this. Each of the side of the pentagons are going to be 11, correct? So very good. We know that this is the part that's going to wrap around the edge of that pentagon. So each one of these sides are going to be 11. Everybody agree? What is 13 called? The height. Very good. It's the line that connects the two pentagons. Right here, look, this is going to be 13. This line right here is going to be 13. That's the line that connects the two pentagons. So all these lines right here are going to be your height. The 7.6, what is that called? This little line right here, what's that called? We used it in the formula right here.
The big. Oh, no, it's not.
It's the what? That's your apophthegm.
Yeah, the pocket.
It's on the inside of your
Wait.
pentagon.
Are you serious?
I'm serious
Why can you do that to us?
because it's evil and I like it.
Yeah, you and this one chance.
I know. Let's look at number 5. Just know that this shape right here could really also look like this. Okay, this piece can look a lot of different ways depending on the radius of the circle and how tall the cone is. What I really want you to notice is that this piece right here is nothing other than the circumference of this circle. Okay? Because if I pull this shape out here, okay, here's my net, I open it up. Notice that this piece right here just wraps around that circle. Are you with me?
So that means that flat thing.
This blue line right here is the same thing as the green line. This blue line is the same thing as the green because it has to wrap around to form that cone. Everybody understand? Okay, so in other words, this green line is the circumference, which is 2 pi r, right?
Yes, well.
So they tell me the circumference and they ask you how long this is.
Is that your arc?
It's the same thing. It's the length of the arc. That's why we were using the circumference formula. Excellent job. Okay?
I got